Okay, I'm gonna try to go over some oscilloscope basics for checking your signal levels or setting amplifier gains. The main thing is how to understand and connect the oscilloscope. You'll have to pardon this setup. This is just a quick temporary setup. What I've got here is a the DS0-TC3. This is a good unit. It's got a signal generator in it as well as an oscilloscope. It's about 40 bucks. First thing, if you've got multiple inputs or outputs, make sure you figure out which one is the input for the oscilloscope. And this is a BNC connector, which goes into an adapter for these like extra small connectors. And what this particular cable is here, I'll just disconnect it. This is an RCA cable, as you can see, with an adapter. This will let you plug this line directly into the back of a head unit or the output of a crossover or DSP, or if you need to connect it to a the end of an RCA cable, you've got keep an adapter handy, and now it'll plug right into an RCA. And for this example, I've got some of the kicker test tones going. This is a 1000 hertz tone, a 0 dB, and it's looped. Make sure you loop it. And just temporarily, I've got it plugged into one of the outputs to my amp. This is all temporary, so don't worry about that. But I got 1000 hertz tone going in here. It's going up to the oscilloscope. Now, in order to focus on this, there's a few things we need to do. Let's start with the basics here. You, depending on what model you have, you can go through a signal generator. There's some other tools, component tester. But oscilloscope, hit OK. What you want to make sure you have set is AC. That's the main thing, because if you have it set to DC, you're always going to get bad readings. It's not going to want to read right. So make sure it's set to AC. You've got a input signal coming in. Let's see. Volume is 19. Basically, we're going to hit the auto button here. This is essentially the auto button, even though it's not labeled. And there is our sine wave. The important thing as far as voltage is the RMS voltage, not the max or the peak to peak. But here's our frequency, which is a 1000 hertz tone. It's a sine wave, so the duty cycle is essentially 50%. And volts RMS is 0.42 RMS right now. Because I've got the signals turned down, so about the most you're going to see in this experiment is about 2 volts. As far as working the oscilloscope or explaining some of the basics, as you can see, there's a grid divided. There's a dividing line in the middle here, vertical and horizontal. Your sine wave is usually going to be centered on this horizontal, and this vertical scale right here is going to be your voltage. And right now it's set to 200 millivolts per division. That means each one of these lines here from here to here, that division is 200 millivolts. So 200 there, 400, 600. And you can see with 600 on the bottom half, 600 on the top half, that's peak to peak is around 1.2, which is what we're seeing here. Okay, so if you change this unit, it's going to make your sine wave get smaller or larger in this direction, which is your voltage. Now on this unit, the basic controls are hitting this button. You see this turn blue. This is just going to move the sine wave up and down. I'll show that real quick, but I'll hit the down button. See how the sine wave's moving down? We're going to keep that centered just for the sake of things. Keep that centered. Okay, so we're going to go over to the next one. That's our voltage. Now watch as I reduce it. We're going to go down to 100 millivolts. See how the scale got bigger? So we're going to make it smaller. We're going to go up 200, back to 200. The next step up is 500. That's half a volt. So that means from the center position to this first division line, that's half a volt. Okay. So I hope that makes sense. We're going to move over to the next one. Now the X1 and X10, this is just to change the voltage reading up here, like a different scale. And the only time you would ever put this on X10, and you don't even have to put it on X10, but that is when you're testing your amplifier output and the AC voltage goes above 40 volts RMS, because these units are typically limited in voltage to about 40 volts. I know this one is, and I'm pretty sure the DSO 152 and 153, those are also limited to about 40 volts. So if you're doing the output of an amplifier on the speaker lines, your voltage levels could exceed 40 volts. You know, it could go up to 80, 100. So in order to use this device on a high-powered amplifier, you're going to have to use this probe. You know, this is a more traditional oscilloscope probe, and it's going to have the switch on here. So in order to use this, you would have this clipped onto your speaker wire, like your subwoofer, one of your two subwoofer speaker wires, and then the other terminal here clipped to the other wire. I can kind of show that. This is your subwoofer connectors right here, these two channels. So you'd clip one here to this wire, and then the other one would clip onto the other wire. And you're going to want to flip your switch from 1x to 10x. And what this is going to do, it's going to reduce the voltage by 10x. So if you have 100 volts coming out of your amplifier and you switch this, it's going to reduce it by 10. So 100 is going to drop down to 10 volts. So the signal coming into your oscilloscope is going to be 10 volts, which is a safe voltage for it to read. Now the thing is, your oscilloscope doesn't realize that the voltage is actually 100 volts. It's going to show 10 volts. And if you keep that in mind, you would know to multiply your RMS voltage. If it shows 10, you know it's actually 100. If it shows like 7 volts or 75 volts, you know that's 7.5 volts would be 75 actual volts. But if you don't want to do the math, you can change this setting to X10, and it should just bump up. Let's try it. Let's switch it. See, right now it's showing 0.45 millivolts, or actually, if I'm going to say 0.45 volts, which would be 450 millivolts. But anyway, let's switch the X1 to X10. See, basically it just jumped up to 4.5 instead of 0.45. So this just basically multiplies your voltages by a factor of 10. That's just to help you understand what your actual voltage is. That's all it is. It can be helpful, but normally you would keep it in the 1x mode. Okay, moving on. This next unit here, this is your time domain, and what this is showing is 500 microseconds, and the time domain goes left to right, and just like with the voltage, you have these divisions. Come on, focus. Okay, so from here to here, that's 500 microseconds. From here to here, that's another 500. So from here to here, that's going to be, I think, 1 millisecond. We can change the scale and you'll see what's going to happen. Okay, so 1 millisecond, you see how they all squeeze together. Now you've got 1 millisecond between here and this next, come on, focus, this next division line. Hopefully you can see these divisions, but that's what it means. 1 millisecond here to here. So this would be 2 milliseconds, 3 milliseconds, 4 milliseconds, 4 milliseconds between here to here. And yeah, you can just change that to, if you want to. Normally the auto setting is going to adjust it pretty nicely. Okay, the next unit, what do we have? Okay, AC. The only options here is AC or DC. If we put it in DC mode, it's still showing the AC signal coming in, but all your voltages are now reading incorrect. So it'll show the signal, but it's not going to show you what your voltage is. So normally when you're setting gains or your head unit output voltages, those are all AC. So you'll probably always keep it in AC mode. Now we're going to go on to the next thing. Okay, this little blue line over here, this is the trigger voltage, and you can move it up or down. And you typically won't need to mess with this, but this is set very, very close to the center line. I will move it up just to show you what happens if your trigger is set higher than the voltage on here. Oh, it's still showing. Yeah, normally it wouldn't show the sine wave because the trigger voltage wouldn't be high enough. But we're going to put it roughly back in the same place. Okay, so that we're going to try the next whatever adjustment. Okay, so what's changed up here is the this is what the trigger is looking for. It's looking for a up signal, which means whenever the signal goes above this center line here. So like, I mean, this is more useful for like when you're looking for the initial pulse and initial signal, where it starts to go from nothing, where it starts to rise up. You can set your trigger voltage to catch it on the where it rises up, so you can see how a signal goes up in voltage. And then you can change it to the down, like if you have a high voltage, or a higher than above the center line, and the signal suddenly stops where it drops, it can detect when it drops and show you, the voltage profile of it either going up, rising, or the voltage profile of it going down. Now that's not really something that's you're going to use when you're setting gains, but that's what that means. It's basically just a rising or falling trigger, and I'll keep that on the default. Okay, the next one. That's auto. That's what I've got in right now, but I can switch to, oops, let's go back to auto. If I go up or down, I can switch it into a normal mode where I can change, where it's not getting an automatic signal. I probably would just always leave it in auto. And single, I'm not actually sure what that means. We're going to keep it in auto. And so I think I've covered everything. This moves your sine wave up or down in the window here. Your voltage divisions, for each one of these lines. X1, your time division going left and right, and AC. And what we're going to do, I'll just turn my volume way down so that the signal's real weak. Okay, so you can't see it very well. We're going to hit the auto button, and it's going to readjust itself. You see how it switched the voltage and the time scale. Well, actually the time scale is the same because it's still 1,000 hertz, so that's not going to change. But since I lowered the voltage on the head unit, it automatically adjusted the voltage division. And if you are turning your volume level up, it's going to go off the scale like this. It doesn't mean it's clipping, that just means it's off the scale. And we're going to hit the auto button again. See how we are switched over to the 500 millivolt scale. And I'll turn the volume up higher so it's off the scale. Hit the auto button. Now it's going to adjust it to 1 volt. So that means from here to this first division line, that's 1 volt. That's 2 volts. And you can see the voltage peak to peak. Yeah, it does actually go a little bit past that. But from this peak to that peak, you have 1 volt here, 2 volt, 3 volt, 4 volt. It's actually a little bit more, so you have 4.3 volts. Hopefully that makes sense. Your RMS voltage is essentially, we can take your peak to peak, cut it in half, and then multiply that by 0.7 to give you your RMS. But what's nice about these particular units is they automatically calculate your RMS voltage, so you don't have to have a calculator handy. So it's telling me that my RMS voltage is 1.53 volts. And let's see, since we want to look for distortion, I wanted to max it out just to show you what a little bit of distortion looks like. I can't make it distort a lot, but I'm going to turn up my head unit voltage here, or volume level, to the max, 36. And it looks pretty clean, but there's actually a little bit of a change. Let's hit the auto button. Okay, it's hard to see. So what I'm going to do, I'm going to change my time domain. I'm going to cycle through. I'm going to change my time. That's the wrong way. There we go. I want to get a real good look at this sine wave here. And yeah, that's just a track resetting. But we have, let's reduce the voltage, or actually increase. Oh great, I went above the trigger threshold. Okay, so we're gonna stick with this 1 volt. But you can see how there's a slight bit of distortion. This technically is kind of like clipping, but this is so faint you're not actually going to hear this. If I'd reduce the volume level 1 notch, we're back to a perfectly smooth sine wave. But if I go up in volume, you'll see the sine wave, it'll start to distort. Now if it was clipping, it would be more of a flat line. But this small amount of distortion is basically, this probably isn't 1%, or it might be close to 1%. You know, it would be difficult to hear this. You definitely wouldn't hear this on a subwoofer, but on a mid or a tweet, you might hear that. That might change your tone slightly. But I think that covers everything that I can think of. You know, I know different people have different model oscilloscopes, so the controls are going to be different, but this should be most of the basics. Like I say, it really does come in handy to have this adapter for an RCA plug. Other times you may have to use traditional oscilloscope leads like this, if this is all you have. And a lot of these oscilloscope kits will come with this style of connector, and this is the small one. It'll plug directly in without an adapter, and I can connect this to my speaker leads. But you don't want to use these with high voltage speaker leads, like anything over 40 volts RMS, like I said, because you need to have that X10 switch ability. If you're going to use high voltage, you have to use this probe, and you have to make sure it's set to X10 so it'll drop your voltage by 10x. That's the only way you're going to set the gain on an amplifier that is, I think, over 400 watts or so. Because I believe 40 volts at 4 ohms is 400 watts. So if you got like 1,000 watt amp or bigger, you're definitely going to have to use this probe. You have to connect this to your speaker wires, and then set your, you'll have to know which track to use. Right now I'm using a 0 dB, but if you're setting your mids and tweets, you might want to use a -5. There we go, -5. And if you're setting your sub up, you would use, for instance, a 50 hertz, probably -10 for setting up your sub. Anyway, that's it for this video. Hopefully it makes sense. And if you have any questions, just leave them down below. I'll try to answer them for you. Thanks.